4.2.11, that question, find a rational function that meets all of the following criteria. So a vertical asymptote. So vertical asymptotes come from the denominator. So in the denominator, because x's can't equal these or you'd be dividing by 0, and x plus 1 for the negative 1. If you set this equal to 0 and undid it, you'd get a negative 1. So negative 1 plus 1 would be 0. 0 times anything is 0. Can't divide by 0. So any other one, and x minus 7. So vertical asymptotes come from their check. A horizontal asymptote, that's the one I talked about just in the last video. If you have a 9/4, that means you need to end up with like a same degree in the numerator and the denominator. And then it says there's an x-intercept at -4. Well, that comes, the x-intercept at -4 would be x plus 4 in the numerator. Because an x-intercept is when y equals 0 on the x-axis, y equals 0. Well, what makes this fraction equals 0 is when the numerator is 0. So x couldn't be -4 here, or x equaling -4 would make the whole fraction 0. It seems like we need one more thing though, because if this horizontal asymptote is 9/4, right now I have the degree on the bottom larger, so that would be something over an infinity when we got done, like I explained in the last video. So that would be on the x-axis, or y equals 0. So I need to have another x up here. So there's something else that's in the problem somewhere. This one down here would be good, except we'd have a horizontal asymptote at 0, so that's out. If you multiplied this denominator out here, you've got x squared minus 6x minus 7, but then all of them times this 4 out here. So you've got that 4x squared minus 24x minus 28 in the denominator. So this one doesn't have our 9/4, so that is out. And then the last one would be in the numerator then. It looks like 9 would go into all those. It looks like 9 would go into all those. So then what we would have to be left with is which of these two here have this x plus 4 as a factor. So if I'm going to quickly do a synthetic on that, that'd be -4 for the 0, and take it out of the 9, -27, -252, and see if that is indeed a factor of it. So I'd bring down this 9, -36, -27, and -36, just to make sure I don't make any mistakes. -63 times the -4 is 252. So that seems like that works. What about the other one? If I try taking the -4 out of the 9, +72, +144, and see what happens there. So that'd be 9, -36, that'd be 36. -4 times 36 seems like -144. That seems like that works as well. So what's wrong? One of these must have something that doesn't work in them. And the denominators are identical. I wonder if one of them has something where a factor in the numerator and denominator cancels out with the other side. So let's check this out. This one, if I factor the 9 out, I'm going to have x squared minus 3x, and 252 divided by the 9 is 28. 4 times 7, so that would work. And then the denominator, if I factor that 4 out, it would be x squared minus 6x minus 7. So this would be like 9x minus 7, x plus 4 over 4, x minus 7, and x plus 1. So a problem here is because these x minus 7s cancel, that's actually not a vertical asymptote. When this happens, because the graph's going to be determined from these other parts that are left, it's just that x cannot be 7, or so that is a whole, not a vertical asymptote. So that's a kind of a lot to look for, but there's a lot of things to consider there. So, whoops, that's the one we don't equal. Needs to be the one C. Lots of stuff to consider when you're working with these problems that deal with all of the asymptotes and the rational functions.